Hello everybody and welcome to the review video number 3 for cumulative packet number 5. If we start with number 13, we want to find all the zeros of the following function. And for those that are interested, this is from Unit 8A. So whenever we want to find zeros, the first gut instinct is to factor. And if I look at this problem and I am finding zeros, so I want to set this equal to 0. I'd have 0 equals x to the 5th plus 3x to the 4th plus 5x cubed plus 27x minus 36x. I notice that there's a greatest common factor of x, so I'll take that out. Left with x to the 4th plus 3x cubed plus 5x squared plus 27x minus 36. If I'm trying to find all the zeros, if I don't worry about this piece first, I know if I set this equal to 0, I do have one 0 so far of just 0, 0. So there's 1. And because it's an x to the 5th function, it's possible we could have up to 5 zeros. Now, if I look at this piece of what's remaining, I can't group it because I have 5 terms and not 4. Doesn't look like I have any more GCFs, so it looks like I'm stuck. Until I remember that my best friend is my calculator, and my second best friend is synthetic division. So what I want you to do, and feel free to grab your calculator if you'd like, I want you to graph this function in your calculator and see if you get something that looks like this. So if I get rid of this, see if I can get to my graph, I notice that my function, I graphed it right here, I have 2 zeros at -4, 0 and 1, 0. At least those are the ones that I can see. So I'm going to pick one of them and then do synthetic division to lower the degree of the polynomial. I will pick 1. So if I go back here, I'm going to write down that 1 and -4 were options. So if I do synthetic division on this piece here, we already took care of the x down here, I would have 1, 3, 5, 27, and -36. If this is a root, I should get a remainder of 0. So if I bring down the 1, I'd have 1 times 1, 4 times 1, 9 times 1, 27 plus 9 is 36, 1 times 36 is 36, so I do get a remainder of 0. So now my function is reduced to x to the 3rd plus 4x squared plus 9x plus 36. And at this point, you can continue the problem in one of two ways. You could notice that from the graph, your other possible root was at -4. So you could do synthetic division again with this polynomial, not the original, but where you ended up, 1, 4, 9, and 36. And if you did that, then you would get 1, -4, 0, 0, 9, -36, and so you'd get 0 again. Now, if you're interested, before I continue, I know there's some people in my classes that prefer here to do factoring by grouping. So if you'd prefer to just factor this by grouping and get the answers, feel free to do so and see if you get the same answer as I'm going to. If we continued this way, though, this polynomial is now x squared plus 0x technically, plus 9 equals 0, which is just x squared plus 9 equals 0. And if I solve this quadratic, it looks like I'm going to get imaginary answers because I get x squared equals -9. Take the square root, so I get x equals plus or minus 3i. So I did end up getting 5 zeros, 3 of them real, 0, 0, 1, 0, because remember this is a root, and -4, 0 is a root or a 0, but I also did get 2 imaginaries of 3i, 0, and -3i, 0. Quintic, or x to the 5th function originally, 5 roots. If I look at number 14, if I would like to solve this function, I'm going to write it a little bigger. -3 times x to the 2/3 plus 2 equals -145. My goal is to get x alone and figure out how many answers I could possibly have. So the first thing I'm going to do is move the 2 over. I would have -3 x to the 2/3 equals -147. My suggestion, and things that I noticed on past tests and past review guides, A lot of you decided to raise this to the 3/2 right away. Please, please, please divide by the -3 first to make your life easier. So you have x to the 2/3 equals negative divided by negative, positive 49. Now, if you'd like to raise both sides to the 3/2 power, I like that very much. These would cross out to be 1 technically. So you have x to the first, or just x, equals 49 to the 3/2 power. Now you could plug that into your calculator, but I'm here to remind you that what this really means is 49 to the 1/2 power, then raised to the third. 49 to the 1/2 is really another way to say the square root of 49. And some of you might recall that if you have an even root, you're taking a second root, a fourth root, a sixth root, you have to have plus or minus because the square root has 2 possible answers. So x could equal plus or minus 7 raised to the third, which would get me plus or minus 243 as 2 possible answers. And definitely feel free on your test to take both of these and plug them back into the original. Both will work. Number 15, solve the inequality by finding critical numbers and then checking your intervals on a number line. Write your answer in interval notation. So in order to get the critical numbers, we need a 0 on one side. So what I'm going to do is subtract this fraction over here. So you have 2 over x plus 4 minus 1 over 2x minus 5 is less than or equal to 0. Now in order to get those critical numbers, we need numbers on top and bottom. So we need to get a common denominator here. So we need to multiply this piece by 2x minus 5 over 2x minus 5. We need to multiply this piece by x plus 4 over another x plus 4. And if I do that, here, I'd get 2 times 2x minus 5. And if I combine them to be one fraction while I'm at it, because now they have the same denominator, both pieces are going to have the denominator of 2x minus 5 and x plus 4. So this is from my first fraction, minus 1 times all of x plus 4. All of this is still less than or equal to 0. You definitely could write both these fractions separately first and then combine them, but I hope it makes sense to you why I just push them together just to make my life a little easier. If I keep simplifying the numerator, again, I would suggest not multiplying out the denominator. If I worry about the numerator, I'd get 4x minus 10 minus 1, but remember that negative has to distribute to both, so it would be minus 1x minus 4 all over. I would not, again, please don't multiply this out. You make your life harder. So on the top, 4x minus 1x is 3x. Negative 10 minus 4 is negative 14. So this is my numerator. And my denominator would be this factored form. The reason I left it like this is now I can talk about my critical numbers. My critical numbers in the denominator are x equals 5/2 and x equals negative 4. If I multiply that out, I couldn't see that. And my critical number in the numerator is 14/3. Now, if we need to check these intervals with a number line, we first need to graph these critical numbers and think about if they're included or not. Because these two came from my denominator, they can never be included because we cannot divide by 0. So negative 4 would have to have an open dot on it. 5/2 or 2.5, I'll write them both ways, would also have to have an open dot on it. 14/3 is a little bit larger than 4, so it would be up here somewhere, so I'll write 14/3. This can have a closed dot though, because the inequality is less than or equal to, and this is considered a 0 because it's on top, so I'd have a closed dot there. And now that we have our critical numbers, we have 1, 2, 3, 4 intervals to check. And my suggestion will be plugging the particular numbers into the reduced version. So if I wanted to look at this first interval here, if I pick a number that is smaller than negative 4, like negative 5 for instance, if I plug negative 5 in the top, I would get negative 15 minus 14, which is a negative number. If I plug negative 5 into the denominator, negative 5 plugged in here would get me another negative number. and negative 5 plugged in here would get me another negative number. Negative divided by a positive is still a negative, which is less than 0, so this interval works. If I pick a number between negative 4 and 2.5, I'm going to pick 0. So here I plugged in negative 5. Here I'm going to be plugging in 0. So if I plug 0 in here, I get a negative on the top. If I plug 0 here, that would be a negative on the bottom. And if I plug 0 in here, I get a positive. So here I'd have a negative over a negative, which would get me a positive, and a positive is not bigger, a positive is not less than or equal to 0, so this interval does not work. If I pick a number between 2.5 and 14/3, this is probably around 4 point something. Let me pick the number 3 in between there. If I take 3 and plug it in the numerator, that would be 9 minus 14, which would give me a negative. Plug 3 here, that would be a positive number. 3 in here is also a positive number, so negative divided by two positives multiplied is still negative, which is less than or equal to 0, so that works. And lastly, a number bigger than 14/3, let's do 10. If I plug 10 in the numerator, I would definitely have a positive number. 10 in the denominator in this piece would be positive, and 10 here would also be positive. Positives divided by positives is more positives, which is not less than or equal to 0, so that interval does not work either. So these are the intervals that worked. So in interval notation, my answer would be from negative infinity to negative 4, not included because it's an open dot, union, 5/2, which is not included, to 14/3, which is included, so you'd have a bracket. So this is your answer in interval notation. Last but not least, something from Unit 7, right here, Unit 7. Write the quadratic function in vertex form. This is vertex form. I'm sure some of you very fondly recall. And we want to get this function in standard form to vertex form. And so to do that, we need to complete the square. But in order to complete the square, we need a lead coefficient of 1. And right now, we have a lead coefficient of 3. So what we'd have to do is divide every single term by 3. And when I do so, I would get f of x over 3 equals x squared minus 8x plus 16/3. In order to complete the square, we need the x squared and the negative 8x alone. So let me subtract the 16/3 to the other side. So you have f of x over 3 minus 16/3 equals x squared minus 8x. Now, we need to add that special number on both sides of the equation. That special number is b over 2 squared, or in this case, negative 8 over 2 squared, negative 4 squared, or 16. So on this side, the reason we complete the square is so we can factor this to be x minus 4 times x minus 4, which is really x minus 4 squared, which looks very similar to what the vertex form is. On this side, we need a common denominator of 16 over 1. So we need to multiply, or we need a denominator of 3. So we need to multiply top and bottom by 3 over 3. So we have 48/3 minus 16/3 plus f of x over 3. These together would get me 32/3 plus f of x over 3 equals x minus 4 squared. Now my goal is to get f of x alone. So I need to move or subtract the 32/3 to the other side. And then I need to multiply every single thing by 3. Multiply this by 3, this by 3, and this. So those 3's cross out, these cross out, this one remains. So my vertex form would be f of x equals 3 times x minus 4 squared minus 32. So then my vertex would be at the point the sign changes inside 4, negative 32. So the reason I put this example here, and Ms. Schwartz liked it as well, is so that we can have you remember the completing the square, because this method is important to know for future things. Thanks, guys.